So a Poisson process describes the number of arrivals in the time interval of t in t equals to k, and it can be written as e to the minus lambda t of lambda to the k and k factorial, where k is just the parameter that's usually given. And a Poisson increment can be written as in the process, in the basic of Poisson process, that of xt plus epsilon minus xt divided by epsilon and equals to yt. They give us a Poisson increment, and the distribution density of this process is e to the negative lambda epsilon times lambda epsilon to the m divided by m factorial, and the expectation of it is just lambda. For the Poisson impulse, we define the such process of a Poisson impulse as follows. First, we set zt equals to d xt divided by dt, and that the definition of a derivative, we have a limit of epsilon to the 0 of yt, and then we'll have the Poisson impulse now. And then we can also find just take the derivative of a Poisson process, so we have the Poisson impulse. And then for a telegraph signal, we have the Poisson process of p of k equals e of lambda t k divided by k factorial. And then where if x0 is a random variable taking 1 or negative 1, then we have a random telegraph, and the graph of it can be written as this, where you have this segment equals 1, and then you have this segment equals to 1, where you have the time period here and here is just random, and you can have like 2, negative 1, and then 1, and then a 1, and then negative 1, that you have a random telegraph signal. And then we can define a random walk in a random process by flipping a coin infinite times. So for random walk, you have h if you flip a coin one time, you have a head, and you mark it as h as the first time, and the second time you will have a head, and on the third time you have a tail, 3t like that, and then you'll have a graph that's pretty similar to the first one, t, 2t, 3t, and then you have a infinite n times, then you have x of nt equals k s minus n k s, where this k here is the number of heads, and this n minus k here is the number of tails.